Assalamu alaikum. Good day. Today is my second presentation. I will explain in this presentation how to set up the load case in the load case editor. This is the commonly used load cases in the Caesar. In the Caesar, there will be some missing load cases, like in the load cases used with the relief valves, the load cases with the displacement, and this will be explained case by case while I'm doing the presentations for this cases. Let's start. This was our model that we had uh, modeled in the last presentation. We need to open the load case editor. Uh, First, to run the load case editor icon, you need to run the check icon. After you make sure that there is no errors, you need to press this icon for the load case editor to open. First of all, if you have your own load case from the previous run, it's okay. If you need to build a new one, what you will do, you just press this icon. This icon will give you the recommendation for the code loads, and the recommendation for the loads in the P31.1 and P31.3 is just the thermal and the sustained uh, weight as a sustained load cases. You will not find occasional load cases. Occasional load cases is left to you to be defining it because the code didn't specify exactly the occasional load case definition. As you can see, you will find the hydro test load case, the operational load case, the alternative load case. I will explain later what's the meaning of the alternative load case. We have six cases, and so you will have six operational cases and six sustained cases. Also, we have the expansion load cases. The expansion load cases is the load cases where the system or the Caesar is studying the displacement and thermal ranges based on the requirement of the code. And this explain why when we was setting up the thermal cases, we had, if you remember, this one was for the operation case where we will put the operational condition, and this one was for the design case. The third one was for the minimum temperature, ambient temperature, and this for the other scenarios where we have three pumps. Everyone is off in one of these scenarios. But let's go back to this uh, load case. We made the load case the maximum temperature will be minus the minimum temperature, so you will have the thermal range, the maximum thermal range that you have with while you are uh, subtracting the maximum temperature from the minimum and vice versa. And this is what you will find it here, that you will find that L2 minus L6 in one of the cases, 1 minus L8, 1 minus L2 minus L6. This is one of the cases that you will find. And from this case, you will need to have the stress, right? This case was also explained by algebraically based on the code requirement. Let's go back to the alternative stress, the alternative sustained load case. This had been defined in 2016 version because of the update which had been done in the ASME B31.3 equation 1b, where the code added the sustained stresses to the calculation of the allowable stresses. Okay, but it was under condition where the hot stresses would be greater than the sustained stresses. Where this happen? Usually, this happen under the support left off. In our case, uh, let me show you an example. As an example, you will find that we have three supports that most probably will be under left off, or it will suffer from lefting off because uh, when the system will be under operation, when this branch will be under operation, it will have an expansion due to thermal effect, and this expansion will reflect that this pipe will will left off from the support, and in this case, this support will not be in action. When the support is not in action, it's named a non-linear support in Caesar. The non-linear support is the support which do not have load affecting on it. In this case, the stiffness of this support will be removed from the stiffness matrix in the calculation. Uh, to avoid and to make the right calculation or to give the right calculation, in this case you need to remove the support. So if we need to do this in the right way and you have the right effect of the supports, the sustained effect of the support on the model, you need to run this analysis, and every time you have an non-linear support, you need to remove this support. That's what we was doing before, that once we have an uplift support, we remove it. So in this case, you will have, for example, you will have a three copy from the analysis, because every time you will need to remove the support, and the force where you will remove all this support. Uh, this can be happen in such easy case like this. But what will happen in all the cases, in the complicated cases, where you cannot remove or you cannot copy the system more than once. For this reason, uh, the Caesar had come up with uh, this trial for the load case, where yeah, or the alternative load case scenario, where he calculate the effect of the sustained effect of the sustained stresses uh, on the system while it is under operation, the sustained effect on the system, while with the condition that will the system see under the operation, where the supports will be removed or the non-linear supports will be removed. And this to satisfy, as I mentioned, this equation or the calculation of the allowable stresses of this equation. Okay, Caesar had come up with two uh, uh, naming or two new methods. The alternative method, which I just explained, and the hot sustain method. The hot sustain method is the alternative way uh, to be used from the alternative method. We usually use this, or it had been proven that it gives much better results with the occasional sustain, and this is what I will show you in the next few minutes, if you give me your time and space for this and be patient with me. Uh, so this is how you will have uh, they will have this occasional or the normal without any effect. This is the normal load case. So let me start to edit the occasional cases. When you need to edit the occasional cases, you need first to make sure that you're already running it in the model, as I showed to you in the case of the model in the modeling presentation. We need to go to the first node, and for the seismic we need to run the uniform load, and for the wind we need to define the wind shape factor. Uh, this one had been defined using the seismic wizard, and I will explain exactly how you can calculate the seismic in the presentation of the seismic and also for the wind. Let's go back. Okay, first of all, we will added extra lines to edit our cases. We will uh, highlight the last sustained load case, and we press on the positive sign and start to edit extra lines. We have here, I think we need extra. We have here our occasional cases are the wind and the seismic. The wind we have wind 1, wind 2, wind 3, and wind 4. Wind 1 is for the x direction, wind 2 is for the negative x direction, wind 3 is for the z direction, wind 4 is the negative z direction. When we study wind, we study it in the horizontal forces only. We don't consider any vertical forces. While in the seismic action, we have the z, the vertical, which is the y, and the z direction. This one, or u1, is for the x direction. What we will do, we will start to build up operational case plus the wind effect and plus the seismic effect. Why we do this? To have the displacement and the thermal effect while we're having occasional load affecting the pipe. So we consider the weight, the thermal, and the operational pressure. We use the conditions for the operation while we are evaluating the occasional loads, and we will add it when we can drag and drop as you can see. Also, we can just highlight it and Control C, copy it and paste it. Control V, make it for a paste, and then you can edit it like this to 3 and 4. Also, we can what we will do in the seismic, we will in the seismic usually, actually, let me explain something. Uh, for the normally the people what we do, they consider the seismic like this, uh, the horizontal case separate than the vertical case. L- They do it like this. One in the positive and one in the negative. Some people prefer to do it like this, but based on all the civil codes that we are using for evaluating the seismic effect, we they requested to consider the vertical load. The ASCE specially requested to make addition for the loads. So I prefer to add uh, it to the uh, to the uh, to the horizontal uh, load case. How we do this? We added it in the positive and the negative ones. Then we consider it in the down direction. So you make a copy and go here and insert. Okay. Also, you need to do the same here and then change the sign to negative. Change the sign here to -2. Also, you need to consider here the vertical, vertical, and Control C, Control V. Okay, all of these cases considered operational, operational, operational. Now we need to name this operational case. So operational in Okay, this is the operational case considering the occasional load. Now we need to signify the occasional stresses to apply the hot sustained cases, how we and satisfy and comply with the code requirement. How we do this? We will do it by subtracting the operational case from this case to have a pure wind or a pure seismic. How we will do this? Uh, it's an algebraic combination. We just drag and drop and mention it accepted as algebraic, 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 algebraic. Then go to the operational case. Just drag and drop and we find it. It's subtraction because we consider algebraic method. The algebraic method is the method used in the subtraction in the load combination in Caesar. Also Control C. Okay. This type, it would be occasional. So you need to consider it occasional here. And as you can see, the combination is algebraic. Now we need to consider the hot sustained. How we can do this? We will add it, the sustained load cases, the operational sustained load cases to this pure case. And this based on what? Uh, it's a paragraph which had been mentioned in, I think, paragraph 13, 319.2.3. Let me check. Yes, this paragraph in the displacement mentioned in the evaluation in evaluating systems where supports may be active in some conditions and not others, like piping lifting off support. This difference in strain may be influenced by the change distribution of sustained load. In such cases, the displacement strain range is based on the algebraic difference between the calculated positions of the pipe that define the range. In addition to displacement strain, each calculated position shall include the sustained loads presented in the condition under evaluation of, this is the equation 1b for the allowable stress SA. Okay, this is why we are doing uh, the alternative stress and the thermal stress, or the hot sustained stress. So what we will do, that we will added these cases in the time as a scalar. You can use either scalar or absolute, because in the end of the in the end of the case, in the end of the day, you needed the only the stresses. You don't need the displacement or forces. If you need the displacement or forces, you will use only scalar. But since we are need stresses only, so absolute or scalar will not make a difference. It will give uh, the same output. So what we need to drag and drop scalar a scalar scalar scalar. to add extra. Now we need to go to the sustained case, operational sustained case, and start to add it. Once we add it, you'll find it's added it where we use a plus because we already used scalar combination method. And sustain, sustain, plus. We can just copy. Okay. Also, this will be occasional. Stress type is occasional. Okay. Uh, this one. Since that this load cases are just used for the calculation, not needed in the code compliance, so you can suppress these cases so you're not getting confused in the results. Also, you can suppress the alternative cases. Okay, this is the way that we setting up our load cases. Let me go further and expand some details in the load editor that you will need it. If you remember, while we are doing the model, we run the ASME B31.3 flange leak check to activate this on the analysis. While you are running the analysis, you need to go to the flange analysis temperature column and select which temperature you need to be uh, uh, compared to inside the analysis. So for each operational case, you will use the temperature case that it's used by. Uh, Also, the friction multiplier column. The friction multiplier column is either zero or 1. Let's save this first. Warning, the occasional load combination sustained case. The combination method is either scalar or absolute. Let's return back. Some of the cases, looks to me that some of the cases are scalar. Scalar. All of it is scalar. Oh, this algebraic. Yeah. So let's save it again. Yes, it's saved. Let's cancel and go back to the model. If you remember, while we was doing this, while we was modeling the supports, we put the friction factor. So if you need the system to use this friction factor, you either use 1 or you either use 0 to consider the friction factor. Also, in the sustained cases, in the sustained and the occasional cases, you mentioned that it should be automatically it will be added that it should be studied under the minimum hot sustained in the case. Also, you need to consider the effect of the snappers in case you use the snapper in the wind and in the seismic case. So you need to activate uh, this check marks to activate the snapper in the design if you request it or you install. Uh, After that, we need to define the wind. It's defined here, but I will explain to you how to define it. You choose whatever the code that you needed. Uh, for me, I use the ASCE 7 based on the project requirement. It's not from my mind. Uh, Whatever is 10 or 16, I'm using the latest. You will enter the wind speed. You will find the wind speed in the site conditions. The exposure, also in the site condition, it will give you the exposure, or you can consider it from yourself by your experience. The structure damping factor is 0.03. This is default. We don't change it. If you have a structure natural frequency, you can mention, but you really don't have it, so we leave it like this. You will know the also from the site condition, it will give you how much high you are from the surface of the sea. In case you have hills, you need to mention you mention it here, but since we don't have hills, I consider no hill. Here, where we define the direction, I'm defining the first uh, wind case in the x direction, so I mention 1. You can make a copy of all the data for the other 3 vectors. And now, if we went to the wind case, you will find the same vector, but I need the second case to be in the negative direction of the x. The third case, I don't need it in the x direction, but I need it in the z direction, so I mentioned 1. And the fourth case, I don't need it also here. I need it in the negative z direction. Uh, After that, press save. You go back here. Also, if you need to export this load cases to Excel so you can use it in other calculation, you just can press on this icon and it will export this load case to Excel. As you can see, it will be shown like this. Also, if you need to import it back, you will press in this. Either you have imported load case from other calculation, or you can import it from the Excel by selecting this and import it back. As you can see, it's imported. That's all for the load cases and how to build up a load case scenario or the load case for a calculation inside the load case editor. Remember, this is not all the load cases that you face because there is others where I will explain it case by case. When we use hangers, you have a different load case, you have a different update. When you use forces, extra forces, when you use extra displacement, this all will give you extra elements here or extra input where you will put it here. But I will explain it case by case while we are going through in our presentations. Now what we will do, we just need to run the analysis. We have a case where we have, uh, as I mentioned, see here, we have convergency in node 21 and 45. So just we need to cancel and we can go to node 21 and node 45. Let's see them. Most probably they are the supports that do not have that non-linear supports that I already showed to you. Okay, this is the 45. Let's rerun it again. See, also the non-linearity is considered by the gaps. Also, you can suffer some convergency due to the gaps that you will added, but this is part of the fabrication, so you need to consider it to be accurate calculation. As you can see, this is our load cases based on what we already shown. I will explain all this output report in the next presentation. I hope you keep watching with me. So I will explain more. I need to explain more and I need to show you more about the Caesar and how to be more professional in the analysis. This is just the start, so just please be patient with me. And if you have any question, please ask me. I'll be very happy to answer and help. And I hope this presentation was well explained. And I wish to see you in the next presentation for the report output. Thank you for watching me.